Hello friends. So today we'll move on the problems on cone clutch. So the reference design data and book is Mahadevan and K. Reddy, 4th edition. Now before going to solve the problem, so the formulas or the equations available in design data and book. So for cone clutch, you refer figure number 13.11. They have provided the dimensions on big figure B and construction of cone clutch on figure A. Now, first equation is the axial force in terms of normal force, Fa equal to Fn into sine alpha. Next, the friction force or tangential force Ft equal to mu into Fn. That is what mu into Fa divided by sine alpha, equation number 13.10b. Next, the relation between the axial force and the clutch dimensions, Fa equal to pi dm bp into sine alpha. Now, torque transmitted through friction, that is what the frictional torque, T equal to pi by 2 mu bp into dm square. Now here the dm is mean diameter, so based on the uniform wear theory. Now alpha is 1/2 of the cone angle, that is in degree. Normally 12.5 degree for cone clutches faced with leather and 15 to 25 degrees for industrial clutches faced with wood. Next equation, power transmitted taking into account the load factor. You can select load factor from table number 12.33. Now based on units SI as well as FES, you can use equation number 13.10E in terms of kilowatt, and if you want to go for in terms of mega horsepower, you refer equation number 13.10F. Now the force necessary to engage the clutch when one member is rotating, that is what F dash A equal to Fn sin alpha plus mu cos alpha, or you can use equation phi dm bp in bracket sin alpha plus mu cos alpha. Okay. Now where mu is the coefficient of friction based on the connection between the cup and cone here. 0.15 for cast iron on cast iron, 0.20 for a surface faced with leather or wood, 0.30 for surface faced with asbestos, and mu equal to 0.25 for cone surfaces with cork inserts. Now P is the unit normal pressure at the contact surfaces. Okay. Now the ratio of the width of cone to the mean diameter, it is noted as a Q dm by b. You can take range from 4.5 to 8. That is what equation number 13.10H. Mean diameter of clutch based on the power transmission as well as the load factor. Okay, you can refer equation number 13.10I. Mean diameter in case of commercial clutches, dm equal to 5d to 10d. That is what equation number 13.10J. Now here the D is a diameter of shaft here. So D is a diameter of shaft. Now you need to calculate a diameter of shaft. Once you got the diameter, then you can select mean diameter 5d to 10d. Now peripheral velocity for high speed, if the clutch is a leather faced, then you can maximum speed is 13 meter to 25 meter per second, and the speed that means when the clutches are metal to metal contact surfaces, then the speed is 5 to 16.5 revolutions per second. Okay. Now these are the formulas required on solution of cone clutch problems. So let us go for a problem here. A cone clutch transmits 180 Newton meter of torque at 1200 rpm. The larger diameter of the clutch is 300 mm and face angle of the cone is 12.5 degree with a face width of 60 mm and coefficient of friction mu equal to 0.2. Now you need to determine axial force required to transmit the torque, axial force required to engage the clutch, average normal pressure when maximum torque is transmitted, maximum and minimum normal pressures. Okay. So let us first notify the given data. Now power P is given, sorry, not power. Now torque is given 180 Newton meter, speed is given 1200 rpm, and larger diameter, that is what DO is given, outer diameter, this is what 300 mm, and face cone angle, that is alpha equal to 12.5 degrees given, face width of a cone B equal to 60 mm, then coefficient of friction F or mu is equal to 0.2. Okay. Now let us calculate the dimensions. I'll go for a solution. Now axial force required to transmit the torque. Okay. So now axial force required to transmit the torque. Okay. So the equation is T equal to F into dm into Fa divided by 2 sine alpha. Okay. Now you need to calculate dm here. Okay. You need to calculate Fa. Now torque is given here. Okay. So the cone clutch transmits 180 Newton meter. To calculate dm, you can use the alpha value. Okay. So let us look over the diagram here. Now this dimension is outer diameter. Okay, this is what D naught. They are given it is a 300 mm. Next, now Di or D1 is not given here. Okay. And what they are given, they have provided the value of B here. They have provided value of B equal to 60 mm. Now what parameter we needed to calculate the torque here? You need mean diameter. Now let us draw mean diameter mark here. This is what mean diameter. Now angle is what? Alpha. Okay. Now this is what? B by 2. B by 2. Okay. Now this dimension is dm. This dimension is d naught. Now this is alpha. Now we can calculate value of dm. So now based on trigonometry or based on this triangle, what will get? So sine alpha equal to d naught minus dm divided by 2 all divided by b by 2. Okay. Now we'll substitute. D naught is how much? It is 300 minus dm, it is unknown, divided by 2. Okay. Now this is what b is 60 by 2. Now this is equal to sine 12.5. Now if you solve this equation, you are going to get a mean diameter dm equal to 287 mm. You are going to get a diameter, mean diameter as 287 mm. So now let us calculate the inner diameter. So now mean diameter dm equal to what? Di plus do divided by 2. Now 287 is mean diameter. We don't know inner diameter. We have an outer diameter. So if you solve this one, you are going to get a di equal to 274 mm. Okay. I think now you got a dimensions. dy is they have given 300 mm. dm is 287 mm. And di is 274 mm. B they are given, it is 60 mm. Already they have provided alpha value, it is 12.5 degree. Now let us calculate the axial force required to transmit the torque. Okay. So now T is 180 Newton meter. Let us convert in Newton mm. Now coefficient of friction is 0.2. We need to calculate the axial force. You got mean diameter as a 287 and 2 into sine 12.5 degree. Now FA is 1357.64 Newton. So this is what first bit of work, that is axial force required to transmit the torque. Axial force required to transmit the torque. Okay. So Fa equal to 1357.6 Newton. So next we'll go for axial force to engage the clutch. So not an equation from design data handbook, there is a FA dash F dash A. It is equation number 13.10G. Okay. Now refer design data handbook, equation number 13.10G. So equation FA dash equal to Fn in bracket sine alpha plus F cos alpha. Okay. Now in this case Fn is a normal force. Fn is a normal force. So now this normal force can be written in terms of the axial force required to engage the required to transmit the torque. So now Fa divided by sine alpha, this is equal to sine alpha in bracket sine alpha plus mu into cos alpha. Now we substitute. Fa already calculated, this is what 1357.64 Newton, sine 12.5, sine 12.5 plus 0.2 into cos 12.5. Now the axial force required to engage the clutch is 2582.1 Newton. So next we'll go for average normal pressure. Now we know equation Fa equal to pi dm into Bp sine alpha. So this is what equation number 13.10c. Okay. Now let us substitute. Now average pressure is going to occur at a mean diameter. Okay, average pressure is going to occur at a mean diameter. So now you substitute dm as a dm itself here. Okay. So Fa equal to pi dmb p average into sine alpha. Now if you substitute it and calculate the values, 1357.1 divided by pi dm is 287, b is 60, sine 12.5. Now average pressure we are going to get here 0.1159 megapascal. Now to calculate maximum and minimum normal pressures. Now we know maximum pressure is going to occur at inner surface. Based on uniform wear theory, so maximum pressure is going to occur at inner surface, as what at inner radii. Okay? So maximum pressure P equal to P max and dm equal to di. Okay? Now use the same equation. Now in this case you go for pi di b P max into sine alpha. Now calculate what's the P max here. We are going to get P max as 0.1214 megapascal. And minimum pressure. So minimum pressure is what at extreme outer surface. That is what dm equal to d naught. So now P minimum is use same equation here also to calculate the minimum. Now what will get P minimum equal to FA divided by pi DOB sine alpha. FA is 1357.1, pi D naught is 300, B is 60 into sine 12.5. So we will get minimum pressure as a 0.1109 megapascal. Okay. I think this completes the requirements.